Hey everyone, and thank you for joining us for today's webinar. My name is Jonathan Duvall, and I'm a senior member at the developer relations team here at Roku. I'm really excited because this is our first Roku developers webinar, so we appreciate everyone participating in this event. So in a few minutes, I'm going to bring in Jeff Dunn, senior software engineer at Roku and the creator of the BrightScript Profiler. We're going to play a pre-recorded video where Jeff talks about the importance of memory management for Roku channels and then gives a demonstration. He's going to show you how to use the BrightScript Profiler to collect memory and CPU usage data on a channel. And as a reminder, this is the first of a two-part series. The next webinar, which is scheduled for the same time next week, will focus on analyzing the data collected with the profiler. So this week is all about collecting data, and next week is about analyzing the data. So when Jeff's done, we're going to do a live Q&A session where Jeff will answer your questions. This includes questions you provided before the webinar in our Google form and questions that you can answer during his presentation in the Q&A window. So please be aware that while we won't comment on a roadmap or making other forward-facing commitments during the Q&A, we do welcome feature requests and other suggestions around what would make the tool even more useful for you. So as a reminder, during the webinar, your video and audio will be muted throughout. If you have any questions about the material being covered, just enter them in the Q&A window in Zoom. And you can always use Zoom's built-in raise hand feature, which will allow me to enable you to unmute your audio and ask your question verbally to Jeff. So when using this feature, be mindful that all attendees on today's webinar will be able to hear your question, and we will try to answer as many questions as we can. So by the way, if you have to leave early or you want to share this webinar, we are going to post a recording of this on our YouTube channel, the Roku developer sites, and our Roku developers channel for download in the channel store. So without further ado, let's get started. Jeff Dunn, everybody.
All right, thank you, Jonathan. As Jonathan mentioned, we're going to talk today about using the BrightScript Profiler to collect data on your channel. So we're going to cover a fairly simple channel just to give you the basics on how to collect the data. So, and why is channel performance important? Of course, it's important for all software, but in particular for Roku devices, because a lot of the Roku devices are quite inexpensive. I think the low end is $29. And obviously at $29, you can't sell a very high-powered device. Now, these devices do work very well, but you have to make a little bit of effort to make your channel run smoothly. So we're giving you the tools to help you do that. So what are the common things we see? A channel that either uses too much CPU or consumes more memory than necessary. Either just plain bulk, just allocates more memory than it needs. Or what happens too is a channel will allocate memory and then leak it. You know, it can be argued that on a reference counted system like BrightScript, maybe you don't technically get leaks. I tend to define a leak as any memory that can never be used by the channel again. Basically, if there's no user path that will ever access that memory again, then it should be freed. That is a leak. And those leaks can add up. The channel will end up being killed because of low memory conditions. So here's a picture of our visualizer tool, which we'll be using quite a bit today. You'll become familiar with that. And so specifically what we're going to talk about is how to use the profiler, how to configure the channel, what profiling commands are available, the different ways of collecting data. And then we're going to do some demos of actually doing this with channels, albeit a fairly simple channel, but the idea is to make the concept obvious in this session. In the next session, we'll do a little more in-depth with more complicated data structures and some more advanced features in the visualization tool. That said, let's go ahead and get started with the demo. Okay, so what we have here is this is the live output from my Roku 4200. It's a Roku 3. So let's start by looking at our channel manifest. So I'm assuming that everybody here has at least written one Roku channel. So none of this is going to be terribly advanced, but if you packaged one channel, this should all make sense to you. So let's look at our editor. I have an editor up with our manifest in it. So here's our manifest. It's a typical manifest. Oh no, sorry, that's not the manifest. There's our manifest. It's your typical manifest, usual options. And here are the profiling options we're going to look at first. So the way the profiler works is everything is done through the channel manifest. You put things in the channel manifest. It's very akin to other systems where you have to recompile the profiling turned on. In this case, you change your manifest to say that you want profiling, and then you run the channel. Once the channel is running, there's really no way to turn on profiling it. You have to do it before you start the channel. So you always have to have BSProf enable equals 1. And no matter what other options you've got set for profiling, they're all ignored unless this is set. The other thing I'm setting here is enable line, BSProf enable lines to 1, which is of course true. This is a Boolean value. As you know, in manifest, typically use 0 and 1 for Boolean values. So what this does is it collects the data, both CPU and memory, with line numbers. With this off, you just get it by function. And the reason that exists is if your channel is big and you've got a lot going on, you can overload the system. With profiling enabled, your channel just might be too slow. You just feel it's just very hard to use and get to where you need to profile. If you set this to 0, it'll do it by function and just produces a lot less data. Now, in practice, we've improved the performance of the profiler enough over the last couple of releases that this isn't usually necessary. So I'm just going to turn it on and we're good to go. So again, typical channel packaging, you zip this thing up. Oops. Sorry. So we build our channel zip file. And now we're going to go over to our application installer. Oops, that's not what I want. So here's our application installer, which everybody again should be hopefully familiar with. We go to the installer. So the channel installer, everybody probably knows this, but it's just the IP address of the Roku device. And you get this page, and we're going to say upload our new channel. And there it is. And replace. And make sure it takes it here. There we go. So channel uploaded. So I'm going to go over to our. So again, this is the live output of the Roku device. And the only option for this, because it's a simple channel, is start test. So why don't we go ahead and start the test. So this channel just goes through a loop and it allocates memory and it frees memory and it allocates memory and frees memory and allocates memory, frees memory. And as you can see, the number is going up. So we clearly have this app has a problem. It can't run forever. It's going to run out of memory eventually. It has some sort of leak or something. So to terminate this session, you just leave the app pretty much any way you feel like exiting. So back will do it, home will do it. So we've exited the channel, gone back to the home screen. I pressed the back button there. And so if we go over to port 885, which is our normal debugging channel, you'll see this line here. Profiling data complete, download with application installer. So it's saying, obviously, we've got a complete data set, where to download it. So let's go over there and let's come back to our application installer. Now you go into utilities and click on the profiling data link. And I've got my font size increased to make this easier for everybody in the audience to see. But when you have profiling data, you get this profiling data message. Normally, you don't have to scroll down to see this, but I have to scroll down because my font is so large. And then you get this link for downloading the profiling data. So we're going to download it and save it somewhere. And it looks like a good place for it. So now we've got the data. So now we want to examine the data. By far the easiest thing to do is to use the visualizer tool provided by Roku. And what I'm going to do here is I'm actually going to put in a little plug for our online documentation. So basically, if you want to find the profiler documentation, just go into any search tool, web search tool, and Roku BrightScript Profiler. And there's our first link is the documentation for our profiler. There actually is a link here directly for the visualization tool, but I want to go through the documentation because this is I have to do this all the time. I can't remember these links, and I figured that nobody else can either, the actual URLs. So this makes it easy. And what I wanted to show here is this is the online documentation for our profiler, which we think is pretty good. This is fairly complete. Everything we're going to talk about today is fully documented here. It's available in 9.4, which is rolling out now, Roku OS 9.4, which is rolling out now. Most of these features are available in 9.3 as well, but we recommend people go to 9.4. So all these instructions, these basically cover a lot of what we just went over. There's your app installer, downloading the data, etc. Viewing profiling data. This is now what we want to do. And there is the BrightScript Profiler visualization tool. And I will open that in a new tab. And I'm going to skip tutorial mode because I think I know what I'm doing. So we will talk about streaming data in a minute. There are a couple ways to use this tool, but we're going to use, again, the most common paths for this particular session. So basically, you browse to find your data file. There's your data file. And as you can see, this is pretty small. If you're doing just CPU data, in this case, it's less than a kilobyte. If you're doing just CPU data, the data files do tend to be fairly small. And so you can use the mode that we just used, which is what we call batch mode, saving the data on the device, downloading from the application installer. We'll talk about where that won't work when you have larger data sets in just a moment. So we've loaded our data, and I always like to look at the information provided up here to make sure that I got the right file. So for instance, I know that this is RSG profiling demo. That is a channel that I'm profiling. I did it on a 4200. Looks like the right, and it ran, well, this moments ago. So this looks like the right data set. I want to talk about these ratios just for a moment. So this is requested ratio and actual ratio. And what that is the sample ratio. By default, the sample ratio is 1.0. It's a floating point number, which is essentially 100%. We profile every single BrightScript statement. That's worth mentioning as well. When we talk about CPU, we're actually just counting BrightScript statements. So they're not actual CPU load. It's actually the number of BrightScript statements executed. One of the nice things about that is that it's consistent across devices. Whether you've got a low-end device or a high-end device, while it may take longer to run and your wall clock time may be different, the amount of CPU time is very consistent across devices. So what that means is you can profile on one device, and it's generally pretty applicable to other devices. You should always test on a low-end device before you ship, but you can get really good data that will be applicable to all the devices. So the reason we have this request ratio is sometimes with the request ratio, a sample ratio of 1.0, we sample every opcode, which adds a lot of overhead. If you feel your channel, again, is behaving just too slow with the profiler on and you're not able to effectively use it, you can dial this down a bit. So that's why we have request ratio and actual ratio, is that if you turn on memory profiling, it forces it to 1.0, 100%. I don't want to go into all the reasons for that, but you may request a lower number. If you've got memory profiling on, it will bump this up to 1 automatically. So it tells you that. The other thing it tells you here is you have no memory data to be expected because we have not enabled memory profiling, but we do have line data. Okay, so now that we've got our summary figured out, let's start looking at the actual data. I think it's worth looking at these columns. So what these columns are, let's start with these CPU columns. So CPU self, again, when we say CPU, it's really BrightScript opcodes executed. I'm not going to say that again. It's just throughout this whole demo, that's what we mean. So CPU self is the amount of CPU consumed within a function itself. CPU callees is the amount of CPU used by everything called by that function, the entire call hierarchy under it. And where that can be useful, we'll actually look into this. What that can be useful is sometimes you have a function that is not using that much CPU on its own, but because of the way it's called, you can find various problems. So we'll talk in a little more detail about that in just a minute. We'll probably cover more of that in another session. So CPU is total is basically the total of these first two. And the same with time. We're not going to spend a lot of time talking about time, but this is wall clock time. So again, we actually spent 42 seconds in this function, whatever this is referring to here. So I'm just going to wander down. So almost every, and these are of course the threads in my channel. Every BrightScript, every Roku scene graph channel will have at least two threads. It will have the main thread, which is what calls your main, and a render thread that comes in and out. It's a system thread that comes in to do your rendering, obviously. And you can also have task threads. But at a minimum, you'll always have two threads in an RSG channel. And so let's look at this one, which we see is using a lot of CPU. Let's just drill down here. And which saying thread 2 directly calls two different functions, init and timer fired. Now, this is clearly the render thread because init, as anybody has written in RSG, a scene graph channel, knows init is called on the render thread. And then timer, this is a field observer, and it gets called also on the render thread, or a render thread. So again, we're looking at this, and let's just look at init for a minute. And we're saying, okay, we want to figure out why init is using so much memory. It takes too long to start, right? In this case, this particular channel isn't taking that long to start, but let's just say that it's taking more time than we'd like. Let's look in here and see what we're doing. And in fact, it's taking a half a second to start. So the interesting thing here, so you can, if you hit this arrow here, it expands it. This shows the call stack, right? So this is init calls init test. And if we look at, again, typically what the first place you want to look is in call ease, I'm sorry, CPU self. CPU self is the most obvious when a certain function is just using a lot of CPU within that function. That's a good place to look to start, see if there's something you can do to clean that up. So if you click on this ... this is where, so the two things that are interesting here is if I hover over this, it tells me I'm in the main scene BRS file. And if I click on this ... I actually have line numbers. So this tells me on every line how much CPU is being used by that line of code. You can sort any one of these columns. I'm actually not going to do that. You can do it to, well, I'll just go ahead and do it here. So basically this bumps it up at the top. The thing that's confusing is now your lines are all out of order, right? So I generally will do this, say, oh, okay, well, 39, 40, and 41 are obviously the issues, right? But I prefer to usually look at it like this with the line numbers in the right order. And if you notice that the line numbers are also sparse, you won't have every line in your code, every line in your script will not show up here. What you see here is lines that actually end up using CPU. For instance, obviously comment lines aren't going to show up, and various other code lines that don't actually use CPU might not show up. So in any case, we're saying we know that lines 39, 40, and 41 of main scene BRS apparently have some issues. So let's go and look at those files. So if we look at our main scene BRS, 39, 40, and 41. So sure enough, this is a loop within a loop, and it's just counting blindly. So clearly we have an issue here. Again, what the profiler can do is it provides you the data to show you where your channel is using resources, but it cannot help you fix it. It's up to the channel developer to know what your channel might do. Like for instance, can I count viewer here? Again, this is a contrived example, but you're going to have to figure out, the channel developer will have to figure out how to improve this, but we've localized the problem so you know at least where the issue is. So the other thing I'd like to talk about really quickly is, if you go back here, so we had our threads here, right? I actually usually start off, I wanted to show you this data set because this is kind of the entry points to your channel, right? You see what your channel is doing. You can look at this, and there can be a lot of data on this page alone. Again, this is a fairly small channel, but I usually start with the top offenders list here. Right now it's on memory. We're not profiling memory. Let's look at CPU. And again, usually I find CPU self is a good place to start. So what this says is it's pretty clear that this thing called busy loop, is using a lot of CPU. So what we just looked at, to be clear, was the initialization time. We explicitly looked at it and said, okay, we know when our init time is slow. Let's see what's going on in there. Now we know something is going on in the channel. Let's just look at all the data and see where the worst offenders are. Clearly, this is a top offender, this thing called busy loop. So let's show the call paths there. Click on that. And then let's look at the line data again. So again, here we go. So again, typically the CPU self column is the simplest thing to resolve. It can, again, sometimes you need to look at CPU total versus CPU self. We're not covering that right now, but CPU self tells you the raw amount of CPU is used on that line of code. So clearly these three lines are using a lot of CPU. 110, 111, 112. So let's go ahead and take a look at that. So what we've done here is we've looked at this. Well, here's 110, 111, and 112. Same thing. It's doing a big, just counting to some big number. So what we've done here, the two kind of goals that we just looked at was, one, I know my init is slow. So I'm going to go in and look at that call stack and see if I can figure out what in the init process is taking so long. And also just, I've got general performance problems in my channel. I'm going to look at the top offenders and see what might be slowing us down. So we found a couple of red flags here that we can then address, as the channel developer can come back and look at and figure out how to speed it up. So now I'd like to cover briefly memory profiling. So let's go back and look at our manifest. Oops, shoot. Okay, so let's go back and look at our manifest. Yeah, let's turn on these two additional options that we had commented out before. So save that file. So again, what's going on here is we're turning on memory profiling, obviously. And what that does is it logs every single memory operation done by the channel, allocations and frees. And then ultimately the visualizer then matches those things up to see what maybe hasn't been freed by the channel, what it allocated didn't free. The other thing we're going to do is we're going to stream the data to the network. And the reason is when you start doing memory profiling, you can generate gigabytes of data. Very often, you have a small memory leak, you need to run this for hours. I've run channels overnight and generated tens of gigabytes of data. And everything works well. It actually, you can generate large amounts of data. The profiler works fine. The visualizer tool, while it may take a couple minutes to chew through the data, it does a good job of finding a lot of those issues. But in any case, if you're going to generate gigabytes of data, you obviously cannot store that on the device. You need to stream it off of the device, which is what this data dest flag does. So let's zip up our channel. And let's go ahead and reload it. Where'd my, back up here. So go back to installer, upload, and replace. Go back to our live device and watch this channel start. Do-do-do. And that does not look good. Oh, I'm sorry. So yes. So because I had data destination set to network, obviously it's streaming data off of the device. You have to then retrieve that data. And I usually use wget. Just say you use wget, curl, you can use a web browser, just a normal HTTP link. So okay, so once it can start streaming the data, then it actually starts the channel. So what happens there is, as the channel starts, it waits for a connection to be able to start dumping data, and it will not start the channel until it gets that connection. The other thing is you have 60 seconds to do that. If you don't do it in 60 seconds, profiling is canceled and the channel just starts normally. So not the end of the world, you just have to do it again. So same test, all looks the same. Now I'm going to say start test. And it's behaving the same as it did before. allocating memory, freeing memory, allocating memory, freeing memory, et cetera, et cetera. Now let's look at the size of our data. If you look at our data here in wget, we've got 12 kilobytes so far. Let's just collect a little more data here. Alrighty, that's probably sufficient. So actually, let's go back to port 8085, and I'm going to hit the home button. Here we go. And now you'll see it says profiling data complete, sent via network. So this obviously tells you a couple things. One, the biggest issue is that you know the data is complete and accurate, that you're not missing any data. One of the things to keep in mind with sending via the network, the streaming mode, is that even if something crashes, your channel crashes, the power gets unplugged from the device, memory data is stored. You only miss the last probably few seconds of data. The CPU data, actually, you might lose. That gets typically dumped out at the end. But the nice thing is if you're profiling memory and you've got a long run going on, you stream the data, runs for hours, and something crashes, you still got a good data set. You can actually work with that data set. And I've done that before, and it works quite well. Okay, so now we're going to do something a little bit different with the profiler. So here's our profiler. Now we can load our memory data in here and do the same things we just did. But I recommend downloading the app. And the reason for that is it's just a lot faster if you have a large data set. Again, this data set isn't that large, but I just thought I would give you an example of how to do this. So this is what you would typically do with memory profiling. Again, the reasoning is the data sets can be large, so you want to stream the data off of the device, and then if you download the local version of the app, it's much faster at processing the data. The web tool actually does a surprisingly good job at processing fairly large data sets, but the local version is definitely faster. So let's just go ahead and download this guy. I'm on Linux. Actually, I'm not going to go ahead and, so this is well, I'll go ahead and download it. I've already downloaded it, of course, so I'm just going to stick with the version I've got and not actually save this. But now let's go back to our, just have to unzip that, and then we open up a web browser, and here is our runnable tool. So again, this is, so this is our local version of the visualizer, which is nice and quick and does not need to be full screen. There we go. So again, what we're going to do now is very similar to what we did for CPU. This tool has the ability, now when you're running it locally, the other advantage it gives is that you can actually upload a device, sideload a channel directly from this tool, and you can stream data directly back into this tool. It just kind of simplifies the whole process, and you actually can get a live mode of memory, a live view of memory use. It actually will show you live streaming how much memory the channel has used, which can be useful sometimes. So in this case, so we're going to go in file mode, very much like we did for the web tool. And where did my data go? Oh, you know what? I need to, I'm sorry. It needs to end with BSProf. So let's just do this. Just rename that file. So now it shows up. Okay, so this has got, and this is quite a bit bigger. It's 20.7 kilobytes as opposed to about a kilobyte. Open this guy. Again, we check our information. That all looks accurate. This time we have memory data. We have our check mark here to show that we have memory data. And let me increase the size of this. Hello. Okay, so here's our visualizer tool. And examining the memory data is very similar to examining the CPU data. There are definitely some additional complexities, which we'll get into, some of which we'll get into in just a sec. But in general, the same rules apply. So let's look at memory. So similar to CPU, we've got self and other. The difference with memory is that we can give you the line number where memory was allocated. And the thing is, we generally don't care where it's freed as long as it's freed. And in fact, very few functions, well, it's not true. It's not true that it's very few, but a lot of functions will allocate memory and the memory is freed somewhere else, right? It's very common for a channel to create a content node, which is then used and then destroyed somewhere else. So we don't care. We don't care about usually what's free self is what's freed within that particular function or that line of code. So you know what? Let's go straight to the. So this again gives you our call stacks. This is the same CPU, the same call graph we were looking at earlier. But let's go straight to top offenders. So if you look at top offenders, and again, this now is where we want to see unfreed total. So again, allocation self is the memory allocated by a given function or line of code. I'm just going to say lines because we have line data enabled, and I recommend that people do that by default. So it shows the memory allocated by a specific line of code. And again, and then what we really care about is unfreed total for that function, right? So the two things you care about, unfreed self and unfreed total. So unfreed self is things that are allocated in that function or that line of code itself that are never freed anywhere in the system. Unfreed total are anything that's allocated on the call hierarchy under that function, everything that it calls. And so the allocation total is everything that's allocated. Unfreed total is everything that's allocated in that function and everything it calls that's never freed anywhere. So we obviously have some offenders here. So we have this timer fired. Now let's just go ahead and look into this. So let's look at our call paths and go in here. So again, this is showing in timer fired. It calls a couple of functions. So Alex self, again, Alex self means within timer fired itself, it allocates 15 kilobytes of memory. These are actually bytes. Leak memory allocates, 114 megabytes, but frees a lot of that. And so what we really care about is the unfreed self in this case. Let's try to figure out where memory is allocated that's never being freed. So in this case, we've got this function leak memory. And if we click on that, we get our lines. And it says, again, unfreed self right there on line 86. So if you notice here, what I was mentioning, so on line 88, it allocates some memory, but it gets freed. In fact, it gets freed in this function itself. So unfreed is 0. There is no memory being. So again, we call them unfreed rather than leaks because your channel may use it. It's very possible the channel allocates some memory and continues to use it for the duration of the channel, or it might use it if the user chooses some option in the UI. So it's up to the channel developer to decide whether unfreed is a leak or is actual memory that's in use. So in this case, we see unfreed self on line 86, and that's in main scene BRS. So let's go back to our manifest. Let's go main scene BRS and line 86. Sure enough, that's just increasing the size of a byte array. Kind of exactly what you'd expect, right? And this, again, this could be a leak. Maybe this thing is growing unnecessarily, or maybe it's actually needed data. Channel developer has to decide that. So let's go back and look at the next one. So we've got this thing alloc then free. So what's kind of interesting about this function, let's just dig in here real quick. So again, if you look at alloc self and free self, it allocates 54 megabytes of memory, but it frees 51 megabytes of memory. So it's only got 3 megabytes of memory that's been unfreed. So what's going on there, right? And do we care? So let's look at line 95. And this is what I say, the simplest thing is usually to look at the self options. Sometimes it's more complicated and things interacting with each other, but the good place to start is just which things are the most the top offenders for unfreed self and for CPU self. But let's look at line 95 here. And what is it doing? So what this does is, if you look at this code, it cycles every, I can't remember how often this runs, once a second. It basically allocates the memory, then frees the memory, then allocates the memory. A second later, it frees the memory. A second later, it'll allocate the memory again. So that's exactly what we're seeing here, is that it's allocated a lot of memory, it's freed a lot of memory, and apparently we caught it in part of the cycle where it is still has the memory, right? It's allocated some memory, but hasn't yet freed it. So in this case, as the developer of this channel, as simple as it is, I would say, oh, well, this is intended behavior, right? I mean, I'm clearly intentionally allocated memory here. I'm going to use it for a while, and then I'll free it. So that is clearly not an issue. But what's interesting, I believe, is this data that shows that, you know, the memory is being managed correctly. It's being allocated and freed, and then we're still using some of it. And that concludes our demo. So I'm going to hand it back to Jonathan. Thanks, Jonathan.
Cool. Excellent. Thank you so much. So hopefully everyone found that video useful. Before we get into any of the Q&A, I definitely want to address the issue that was the sort of the scuttlebutt that was going on in the chat regarding the picture quality. Obviously, we were cognizant of the fact that, especially in this demo, we're saying, you know, go look at this line number, and the video resolution is not optimal. So we are working with Zoom to get a, pardon the pun, get a resolution to this resolution issue. So hopefully we'll try to get that resolved before we move ahead with future webinars. So thank you for your patience. And also, when we do post these videos on the YouTube site, our developer portal, and our developers channel on device, the picture quality will be in HD, so it'll be a lot easier to see. So definitely, if you want to go back and watch parts of the webinar where we're pointing at specific line numbers, definitely just check out our YouTube channel or the developer portal or our on-device channel. So great. So at this time, we're going to open things up to Q&A. So Jeff, you can go ahead and turn on your video, and let's just see if anyone has any questions. Sorry, I'm looking in the Q&A room, and I don't see anything. So please, you know, if you guys want to raise your hand or enter anything, that'd be great. And we'll just wait on the line for a few moments to see if anyone has anything. So Brian, if you want, you can, so Brian has a question. Besides the memory that wasn't free, is there a cost of allocating memory that we should be focusing on?
So cost of allocating memory. I would say in general, no. Just like, no, not really. I mean, in BrightScript, allocating memory is just like allocating memory in other system. I mean, there's, other than the memory you're using and the fact that it's an interpreted language has a little bit of overhead. But in particular, no. It's really just the quantity of memory that's an issue.
Excellent. Any other questions? Feel free. You guys use the Q&A, use the chat, raise your hand. I'll wait on the line again, a few more seconds, and okay. So, well, I guess that pretty much wraps up the Q&A session, unless anyone has any other questions. So anyway, thank you so much, Jeff, for presenting today and answering questions. Actually, we just got a late breaking question coming in from Christopher Dwyer Perkins. Chris asks, other than avoiding overflows, is there a slowdown with a large amount of memory usage?
It's a good question. In general, I would say yes, it's possible. It's unlikely. What's likely to happen first is the channel will be killed if it's using more than what's considered a reasonable amount of memory for that platform, which varies by the platform, how much physical memory is available. The channel will be killed if it uses too much memory. And yes, it's possible to get to a point where you're close to that limit and things slow down a bit. But in general, if you get to that point, you're probably going to be killed. The channel's probably going to be killed anyway. So in general, that's typically not an issue.
Cool. Great. So Armand's still typing up a question, so we're going to wait on the line for him. Oh, so Jean Guy has a question. Is there a way to know what the max memory that we can use?
Honestly, I'm not exactly certain. There might be a port 8080 command that would tell you. There are some internal commands that we use, but I'm not sure. Jonathan, can you?
Well, we can.
I'm sorry, I don't know that I can answer that question.
That's fine. We can take a note of that. We'll work on getting an answer after the webinar, definitely.
I believe so, but let's follow up with that, and we can answer that.
Yeah, sounds good. All right, Armand has got his question. It's ready to go. All right, here we go. Armand asks, I frequently use some sort of volatile observation where I create a node, which is a local variable inside a function, and observe a property of this node, which I later use down the road. This local node is garbage collected once the observer callback is executed, or it needs to be explicitly deleted in some way.
In general, you don't need to explicitly delete it, as long as you know all the references are cleared. So let me look at the question again real quick. So in general, no, it's reference counted, right? BrightScript is explicitly a reference counted language. So as long as you drop all references, it should be freed. So if you're saving a reference to that thing in another field, or in M, for instance, then it's a problem. But if you don't do that, then the memory will be freed.
Okay. Christopher Dwyer Perkins asks, are there any plans to add information or commands for profiling to the debug protocol?
We don't have any. The short answer, so to the debug protocol, probably not. They are two separate protocols. And one of the issues there is that the debug protocol is intended to not have dramatic impact on the performance of the channel. The profiler definitely has impact on performance of the channel. So right now we're keeping them separate. Okay. If you have specific requests for things you would like to see, there are potentially things we could add there. So you just get in contact with partner engineering and add your request for specific data that you'd like to see added to the debugging protocol. But in general, no, I don't think we have any plans to add profiling information to the debugging protocol.
Cool. All right, we've got another question from Brian. Brian asks, you mentioned CPU self. Is that CPU instructions or cycles? You said it should be the same number for all processors, whereas wall clock would have what changes?
So yeah, when we report CPU in this data, it is the number of BrightScript opcodes executed. So what that means is that your channel, once compiled or once interpreted on the system, is the same on all platforms. So the number of opcodes executed should be the same, unless you've got different code paths for different platforms, which can happen. But by the same token, the lower performing platforms just take more time to execute a BrightScript opcode. So yeah, the wall clock time will be longer on a lower powered platform for the same number of BrightScript opcodes that are executed.
Excellent. Okay. So we have no other further questions. So I'm just gonna say, last call for questions. If we don't have any more questions, then we'll conclude.
So one of the things I would like to touch on is there was a question earlier, about whether using a lot of memory can cause performance issues. Probably the biggest issue we've seen there is actually texture memory. If you're using a lot of textures and a lot of memory, then you'll see flashing of textures on the screen. So you can see some problems from large memory use. In practice, it's not usually an issue, but if your channel's been killed because of out of memory conditions, then yeah, you might be bumping up to that limit before it's killed. So again, the out of memory killer is probably a bigger issue or low memory killer is probably more of an issue than actual performance of the channel.
So Brian actually has another question. He asks, I noticed the first time the app runs on low-end devices like a 3700, if I benchmark, it takes way longer. Are there things running in the background?
I'm sorry, I'm not sure you mean the first time, so the second time it runs faster?
That's correct. That's what he's saying.
Okay. I guess my first question would be, does it run faster or does it load faster? Because the first time you load the channel, it needs to compile. So, well, the other question is this side loading or from the channel store? So I'll just answer these questions. So in either case, really, the first time you run a channel, it has to be compiled, right? We compile the BrightScript down to BrightScript opcodes. And so that is definitely going to have overhead, but that just affects the startup time typically. And that's going to be true whether you sideload. Now, if it's from the channel store, once it's downloaded, if you run it repeatedly, then it should be able to have the previous compilation results there. Sideloading, every time you sideload it, it's got to compile it. But if you launch the sideloaded channel from the home screen, again, the second time you do it, you shouldn't have to go through the compile process. Now, if you've run other channels in the meantime, then things get flushed out. Again, limited performance of devices, we have to be conscious of how much memory and NVRAM are used. So if that doesn't answer the question, then I guess post a follow-up.
Or like I said, Brian, you can always raise your hand and we can do this in real time,
right?
If you want. So Brian will give you a chance if you want to do that. In the interim, Christopher has another question, and it's sort of like a feature question. So is there any plans or ways to better isolate parts of the code when profiling?
Yeah, and actually in the next webinar, we talk about this. The easiest way to isolate it is and this is fully documented, is the VS-Prof pause and resume commands. So you can, and in fact, in the next webinar, we'll go through this. So if you want to profile one section of your channel, you pause it, start profiling, do whatever it is in your channel that you want to profile, and then save your data. So yeah, the answer is yes, and it should be documented pretty clearly.
Awesome. That is a great hook for next week's webinar. All right. We're still, any other questions? We'll give about a 15-second wait for the last call. Any other questions? Anyone want to raise their hand? Okay, I think what we're going to do is we're going to wrap this up. So as a reminder, recording this webinar is going to be posted on our YouTube channel, the Roku developer site, and our on-device Roku developers channel in the next few days. So please come back next week, same time, 9 a.m. Pacific time, Tuesday, November 17th, for the second part of this webinar. So we're going to dive into analyzing the data collected with a profiler in order to improve channel performance. So you can register for the webinar by visiting the Roku developers blog, the developers forum, or the announcement channel in the Roku developer Slack. And we look forward to having you guys all back here next week on Tuesday, November 17th at 9 a.m. Pacific time. So once again, thank you so much for attending. This was great. This was our first webinar. We appreciate everyone's attendance and participation. And we'll work on resolving the resolution issues. So, hey, have a great day. And of course, as always, happy streaming.